Like, I wouldn't even, like...
All right, so I want to make sure that you guys understand what we went about doing with you here today. So this is what we're looking for you to do with this warm-up today. The biggest question that people get after trying this is, how do I know which angle is my theta? And the answer to that is, which angle do you want to be your theta? Because you get to pick it. You're like, wait, what? I've got choice? Yes, you have choice. So when you're working with these triangles, if you are working and A is your theta, then that means that your opposite is going to be 56 and your adjacent is going to be 33. 65 is always your hypotenuse. So your hypotenuse is always the side opposite your right angle. That never changes. So when I ask you to write the value of your ratios, if you're talking about angle A, this is my opposite compared to my hypotenuse. Here it is as a fraction. Here it is as a unit ratio. Think back to when we talked about the yogurt. So the unit ratio is when we divide it out. That's how when I give you back your quizzes and tests, you know how well you did. It doesn't matter whether there were 12 points, 22 points, 42 points. You take your numerator divided by your denominator and you get your percent. You get that unit conversation. And as soon as you see an 88, you're like, that's pretty good. It's a B plus. I'm happy with that grade. Maybe you see a 72 and you're like, oh, I need to do a little bit better. That makes sense to you because you're dividing numerator by denominator and putting it into a unit ratio out of 100% compared to 1. We're doing the same thing here. We're taking our numerator and denominators and we're dividing and giving ourselves a unit ratio, a scaled factor that we can use for all similar triangles that are, number one, right, and number two, have whatever angle measurements for A and B. So the interesting thing is, once I divided my opposite of my hypotenuse, my adjacent and my hypotenuse, and my opposite and my adjacent angles, I end up with these three scale factors. You can then go back to this crazy big sheet of numbers that was very overwhelming that you're like, wait, what? And you can try to figure out what angle measure you have. So if I'm looking for where my sine is 0.861, do you see how I'm somewhere in between here? The problem with this chart of values is it's not precise. It doesn't break down into the in-between angles. Your calculator does. So that begets a conversation about, well, why do we have the chart versus just using the calculator all the time? In fact, some teachers never show their kids this table at all. Why do you think this table matters? Why do you think that I want you to see this table?
So we can know like the approximate angles, like things.
Okay, so that you can find it if you want. Go ahead. We talked about the patterns between the sines and cosines. Any other reason why you think I give you this table? Anybody not have a calculator at home? Now you've got a table. If you don't have a calculator, this is how you go about doing this math. And here's something else. I think it's important that kids know that these values existed before they were loaded into a calculator. I don't want you to think that they're magical numbers that just come from a bunch of button pressing. You know what I mean? It's easy to lose sight of where these numbers come from. These numbers existed in the math world way before anybody thought about loading them into a little tiny handheld computer that every student in the building had access to. Think about that. That's crazy. Why did I not bother to fill these in? What do you think? What do you think, James?
Because it's the pattern, like it's the same thing as like the answers. Like,
Yeah, it's just flip-flopped, right? It's just switched. And that's the really cool conversation that we want you to see between angles A and B. Angles A and B are complementary. Complementary angles add up to 90 degrees. So because complementary angles, the sine of one is the cosine of the other. Of course it is. Because as soon as I switch angles, I switch what's opposite and what's adjacent. So we don't label the triangle opposite and adjacent until we know what our theta is. If I know my theta, I know my opposite, I know my adjacent. It changes with the change in my theta. Go ahead.
I think the thing I'm most confused about is how you find the theta on a triangle.
Okay. So I know that some angle, first of all, I love the way you phrased that question. That was perfect. I think the thing I'm most confused about is, boom, I can answer it. It's a great way to phrase a question. If I have this angle, this relationship exists. In fact, all three of these relationships exist. Whether I'm comparing my opposite to my hypotenuse, my adjacent to my hypotenuse, or my opposite to my adjacent, I can talk about any one of these three. You could pick sine, cosine, or tangent. What we end up doing is going to the chart and saying, hey, I want to know which angle measure, here's all my angle measures, which angle measures has this scale factor. When I match up 0.8615, that's somewhere in between here. So I know my angle measure is somewhere in between here. That's a downside of the chart. So then I get my calculator and I can solve it this way. When I turn on my calculator, my first step is going to be to check my mode. Am I in the right mode?
Yes.
What word am I looking for? I'm looking to make sure that it's in degree. If it's not in degree, every single answer you get will be wrong. That's a bummer. That's sad to do all that work and get all the wrong answers. So we definitely want degree. How do I get out of this screen?
Quit.
Second quit. Gets me out. So now, Ethan, because I'm looking for the measure of the angle, when I look at my sine, cosine, and tangent buttons, I'm actually going to consider these blue second functions above them because it's going to give me the angle. So second sine, so I'm looking for the angle who has the sine of 56 divided by 65. I'm looking for the angle that has this ratio between my opposite and hypotenuse. And it's going to tell me that's a 59-degree angle. If I had chosen to do cosine, Ethan, I could have said, hey, calculator, can you tell me which angle has a cosine of 35 compared to 65? And the calculator was going to be like, yo, I told you it was a 59-degree angle. And you're like, okay, just one more question, Mr. Calculator. Can you tell me which angle has a tangent of 56 compared to 33? And the calculator's like, look, we can do this all day. It's a 59-degree angle. So whether I choose to figure out sine, cosine, or tangent, these ratios will give me either the decimal value from the table or asking for the inverse function on my calculator. That's how I get my degree measure. Okay.
Yeah.
Okay. A little bit more clear. So the interesting thing is when I did this originally, I read the chart and said, oh, it's a 60-30 relationship between my complementary angles. And then I did the calculator and I'm like, no, I'm not. No, it's not. It's 51 or 59-31. So the trig table leaves you open to be off if you don't take the time to figure out what it's closest to. The calculator is a little bit more precise. Sound okay? All right, flip over. When we talk about these values, our rule of thumb is as follows. You're going to give me our trig values to the fourth decimal place. That's to the nearest 10,000. You're going to give me my side lengths to 2 decimal places, that's the nearest hundredth, and you're gonna round your angle measures to the nearest whole. We tried to do decimals with angle measures, and it just makes it too hard when you're figuring out complementary, so just go your whole angle up or down. Okay, so this is what we asked you to do in your homework, and I want you to pretend like these two are quiz questions. If you're asked to solve the triangles, I'm asking you to find 3 angle measures and 3 side lengths. Now, in order for us to do any of this, we have to be given 3 pieces of information, so theoretically half the work is given to you. Here's your 2 angles, 90 and 32. And here's the 1 side length that's given to you. Would you classify this as a side or a hypotenuse?
Hypotenuse.
That's your hypotenuse. And you know that because it's opposite your right angle. I'm always going to use the angle that's given to me as my theta. How come? Yeah, it's given. And believe it or not, I messed up on this math last period. I said it was a 48-degree angle. Actually, yeah, I said it was a 48-degree angle. You know how like when you're adding to 180 and 190, you try to do it in your head and you sometimes mess it up? So I said this was 48. Is it 48?
No.
No, it's 58. If I had used 48 for every single calculation, I would have gotten the next 3 answers wrong, right?
Yeah.
So we're not going to do that. We're going to use what's given to us. Go ahead.
So when you're like given a triangle, the theta is whichever one. Like,
You get to pick.
So it could be x or 32.
It could be X or 32. I'm choosing to use 32 because if I make a mistake in this calculation, it'll throw off all my others.
Okay.
So I'm going to choose to use 32, and that makes this side my opposite. That makes this side my adjacent.
Okay.
Once I choose my theta, that tells me what my angles are, and my sine is the relationship between my opposite and hypotenuse, my cosine, adjacent and hypotenuse, my tangent, opposite compared to adjacent. Whether you remember those by SOHCAHTOA, some old hippie caught another hippie tripping on apples. Or I had a kid one year that's like, I don't understand all this stupid stuff you're saying. Why can't we just remember what the relationship is? I'm like, well, rock on. If you don't need to come up with a mnemonic to help you remember, then just remember it, and that's easy too. All right, talk to your group mate. Do these 2 on your mark, set, go. All right, so come back. I want to just talk about this first one because I want to make sure that you understand the different choices that you have when you're solving for these values. I listed what I have. I know I have a 90-degree angle and a 32-degree angle, and I know I have a side length of 25. Those are the 3 pieces of information that were given to me. When they ask me to solve a right triangle, half the work's already done. That's the good news. So when I go ahead and I solve for this angle here, that's just the triangle sum theorem. That's nothing hard. The sum of the measures of the angles in a triangle are 180 degrees. 90 of them are already spoken for. So these 2 values have to be complementary. We're good with that. I'm always going to use what's given to me just in case I oopsed. So the sine of 32 is going to be equal to the relationship between the opposite and the hypotenuse. I know that I used my sine because of all my trig functions, sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, tangent, opposite, adjacent. I know that if I'm looking for the side opposite and I have the hypotenuse, I'm going to use the trig function that deals with the 2 that I got. Those 3 relationships cover all possibilities. When you have a triangle with 3 sides, you can match them each up 3 ways. You can compare these 2, or these 2. So here are my 3 different options. I have my hypotenuse, which means right away I'm dealing with sine or cosine. I'm looking for my opposite. I'm going to use my sine. Truth be told, I'm also looking for my adjacent, so my cosine's the next conversation. I'm not using my tangent because I don't have either of those. So once you determine what you have, that determines which of the three relationships you're going to use. The sine of 32 is equal to this. Now, Mr. Logan and I were having an interesting conversation. I want you to think about this. Which way do you solve it? I use proportions, he uses equations. I'm going to put my sine value over 1, and I'm going to do cross products. That's proportions. Anybody with me on proportions? He does equations. He looks at this equation and says, oh, I just need to multiply each side by 25. Anybody do equations? Couple people? Okay. Is there any difference? Will we all still get the right answer? Rock on.
Because that's what you do anyway with the proportion.
That is exactly what you're doing anyway. That cross products is justified by multiplying each value by our multiplication property of equality. What questions do you have here? Now, you must have a calculator in your hands. You must be pressing the buttons. Math is not a spectator sport. You can't just sit and watch and think you're going to know what to do when you're on your own. So I need you tuning in. All right, take a look at the next one. So the next one, we ask ourselves, what do I have? What do I need? I have my 90-degree angle. By the way, none of this noise is possible if it's not a right triangle. If you're not given it's a right triangle, like, that's not happening for you today. Because we're only using these with right triangles. If I have a right triangle and I'm given a 72-degree angle, I get my 18-degree angle, no problem. You're not surprised I called this theta. I go with what's given, just in case I screwed up. I got a wall full of screw-ups. I know I tend to do things too fast and make stupid mistakes, so I avoid that at all costs. When I go up and I set my proportions, I'm looking at, I have my opposite, I don't have my adjacent or my hypotenuse. No surprise that I'm using tangent and sine, because those are the two ratios that use what I have. I have my opposite. Okay. Tangent of 72 is equal to 12 divided by y. Sine of 72 is equal to 12 divided by x. Now, when my x is in the denominator, it's an extra step when I'm doing my cross products, because I got to get my x out of my denominator. So when I do my cross products, it's going to be y times the tangent of 72, x times the sine of 72, and then I need to then divide. Here's a shortcut for those of you who can handle it. Are you ready? Do you like the shortcuts, or do they freak you out? Last unit, we learned that there was a property of proportions that said, if you have a proportion, you can exchange your means or extremes and have a true proportion. Do you remember that one?
Yeah.
So when my variable is in my denominator, I just switch my means in. I just switch my extremes. I switched y and the tangent of 72. I switched x and the sine of 72. That made it one step less for me to solve and find those side lengths. My y value is here, and my x value is here. That's a 12. Let's see. So I'm going to check and make sure my mode is in degree. My first step always. And then I know that my theta is here, and I'm solving for y. Y is my opposite over adjacent. So my tangent of 72, oops, my tangent of 72 degrees is going to be this, and I want 12 divided by this value. 3.899999. I rounded up.
Oh, what did you? I was going cosine. I'm not cosine.
I'm not going to use cosine because cosine asks that I use my adjacent and my hypotenuse, and I don't have either of those yet.
Oh, okay. Sorry. I was looking at mine.
Yep. All right, so let's go back and look at yesterday's notes. For homework, I asked you to finish the problems on the notes that we did not get to. So we're going to take a minute and we're going to look at this answer key. Check your work with mine for the front. Now I'm pretty sure that we did one together. So our angle measurement for T being 48 degrees and our side length for U and V, I think we did together. For this one, my other angle measure is 25. And my two side lengths, X and Y, 8.83 and 3.73. So number 4 we didn't get to, but I want you to make sure that you have this picture drawn. Make sure you have this picture drawn. Every single time that we give you words without a picture, it's your job to draw your own picture, so that then you know exactly which of those 3 legs, or 2 legs and 1 hypotenuse, you have and you're given. So let's take a look at this. An ADA requirements state that a ramp with a vertical rise of 5 feet must cover a horizontal distance of 60 feet. There were 2 big vocabulary words that we need to make sure you understand. Vertical is up, down. Horizontal, left, right. So our vertical distance of 5 feet, this vertical guarantees that it's at a right angle. So when we use the word vertical, we know that it's going to be a perpendicular conversation to the ground or to whatever flat surface we're dealing with. When we're talking about a horizontal distance, we're going to be talking about along the horizon, and you will frequently get that confused with either the distance of the ramp. They'll ask you how long is the ramp, blah, 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 blah. If you hear or read the word horizontal, you know that that's going to be a leg of your triangle. So when you have a horizontal and a vertical, you know you have a right angle. I'm asking you, how steep is this ramp? What is the degree pitch of this ramp? Because I have my opposite and adjacent, I'm using my tangent. That tangent ratio compares opposite and adjacent. Somebody a long, long time ago measured all of those scale factors for every single degree measure. So I get to go and use those scale factors by saying, hey, what degree has this story? So what the calculator does is it divides 5 by 60, goes through basically the trig table you have on the back and says, oh, that's a 5-degree angle. Now you and I both know it didn't come out evenly, but we're going to round to the closest whole degree. Everyone got that? Sound okay? Okay. On the back of this page, you had a number of ones that I wanted you to try. So I've worked out some of these. Other ones I've just written down the answers. So I'd like you to turn your paper over, and you're going to do one of two things. You're either going to check your work with mine, because you did the work, or you're going to copy down the correct answer so that when you go back and do the work, you know whether or not you got it right. Does that make sense to you? Number 5, when I figure out the tangent of theta is my opposite compared to my hypotenuse, I get what? A 60-degree angle. Right away, I'm so excited because that gives me a 30-degree angle. And then I don't have to do any more math because I know that in a 30, 60, 90 triangle, my short leg and my hypotenuse have a 1 to 2 story. So I get 14 for that side length. No worries. Number 6. I'm given 2 sides of a triangle. I don't have any angles. So the first thing I'm going to do is go figure out what this theta is. And I know the cosine of this theta is my adjacent compared to my hypotenuse. So I enter this into the calculator by using the second function, and I get a 75-degree angle. Once I get a 75-degree angle, I get a 15-degree angle. And at this point, my solving for my long leg is my choice. I can use Pythagoras. I can use more trig ratios. I can do whatever I want. I've got a couple different options for me to get that measure of angle B. For number 7, A and B are 39 and 61. This side length here works out to be 6.4. You go back, you do the math, you see if you can get the right answer. For number 8, my angles work out to be 59 and 31. My side length here works out to be 56. For number 9, it's a 30, 60, 90 triangle. My hypotenuse is double my short leg. My long leg is root 3 times my short leg. 45, 45, 90 triangle. My hypotenuse is 6 roots of 2. So my side lengths are 6. An escalator at a shopping center is 200 feet, 9 inches. That is the length of the escalator. That is the length that I'm traveling when I'm on that moving staircase. There's a 15-degree angle that I ride up. My job is to figure out the vertical rise. I have my hypotenuse, I'm looking for my opposite, so the sine of 15 degrees is equal to my opposite compared to my hypotenuse. Notice I went ahead and I put everything into inches because when it tells me it's 200 feet 9 inches, that's not 0.9. 9/12, 9 out of 12 inches is not the same as 9 out of 10. Are you with me on the decimal conversion? Inches and feet are messy. That's why we should have gone metric years ago. So I'm just going to put everything back into inches. 2,409 inches. So my vertical rise works out to be 623.5 inches. It says round to the nearest inch. That's 624 inches. When I divide by 12, that works out to be 52 feet. All right. You need some processing time. All right, welcome back. I want to talk to you real quickly about a change in our schedule, and this matters because you care about when the test is. So if we go on our Schoology course, of course you see this. It's familiar. We're in Unit 7, right triangles. You click on that. When you go to our assignment sheet, You know you always have the ability to go here and pop it out because then you can see it nice and big, blowing it up if you need to. Here's where the assignment sheet is a little different. Here we are on March 3rd today doing the trig ratios. Your homework tonight will not be the 7-4. It'll be the 7-4 notes and 7-3 practice because up here you finished the 7-3 notes. Are you okay with that?
Yeah.
So you know what it is I'm talking about there. Okay, so tonight you're going to finish the 7-4 notes and then the 7-3 practice. Reminder about the corrections and the retake for the Unit 6 test. That's next week. You can come either Wednesday or Thursday next week. That's fine. Your next class, you'll have a quiz on what we're doing now. This is not going to be, this is going to be homework 7-4. Our review packet is going to come here. Now you'll notice if you're looking at, oops, I forgot my R. You'll notice that your sheet you have in front of you right now is missing this middle row because we missed the dates. So we put the test on the 14th and 15th of March, but this middle row is not included. So instead of putting the test up where we had originally decided, we gave you an extra day of review so that the dates of the test are still accurate. So your next class, you have a quiz on 7-3-7-4, more 7-3 than 7-4. We'll do a little review ahead of time. Then you're going to have a couple of review sessions. One thing that you need to know is that Mrs. Glazier is out all next week. I know. So this whole week where it says Mrs. G out, I will not be here this whole week. So the substitute will be giving you the test, but you need to make sure you have all your questions answered.
Wow.
I'm going to Park City, Utah to go skiing with my family. I'm very excited. So I'm out, but I don't think it's such a bad thing. My plan for you guys while I'm out is you have your unit test this day. That's why I was okay with it. Then you're not missing any content lessons. Just take the test. This next day you have the eCart district test. So, on the 16th and 17th, you're taking the eCart district test. And then the substitute will introduce Unit 8 on this day to you. Go ahead. No, the eCart is just going to be, let's just see where you are right now. It's not going to count for a grade other than completion. Nope. So the way I like to do it for my honors classes is I like to give you the eCart district tests just as we are with what's already sitting in your brains as this is stuff I know. And then the data that I get back from it helps me tailor what we need to review for the SOL and what we don't need to go over because it's already in your brains. Does that make sense? So we don't study for it. It's not going to be a grade that goes on your grade report, but it will be data that I look at. So you need to do a good job because it determines where we spend our time reviewing. Does that make sense? Okay. So awesome. I'm glad we had that conversation. So thank you for asking about that, Olivia. Thank you for asking that about that, Forrest. And I want to make sure that you know where we are on Schoology. Sound okay? Rocco. All right, so we'll go ahead and scoot out. We're going to start talking about our next lesson, which is really just an application of our current ideas. So it's not a big jump. Notice it involves the same trig ratio, sine, cosine, tangent. Did everybody get a note sheet? So I want to make sure that you're with me. So I know you're tempted to do your homework tonight, but do me a favor and don't. Not yet. I want you paying attention. All right, so in this review, Sokotoa, some old hippie called another hippie, however you remember these stories, it all has to do with the three possible relationships between the sides of right triangles. That is the study of trigonometry. We go ahead and we give every single triangle, that's a right triangle, we give it a similar triangle and a scale factor. Those values are stored in your calculator or on the trig sheet. Does that make sense to you?
This is awesome. But did you, bring the tools that we did?
No, you're gonna get them back right before your next quiz. Okay. So now in the application of this conversation, we end up having to make sure kids understand the difference between your angle of elevation, which is where you're looking up at things, and your angle of depression, which is where you're looking down at things. These two angles are always going to be measured from the horizon. So when we're talking about our angle of elevation or our angle of depression, those different angles become important that as long as we know that we're measuring them from a horizontal line. Whenever we're drawing our triangles in these application problems, we want to make sure that we pay attention to key words. We want to make sure that you know that every time you hear the concept of vertical, that represents an up-down conversation that forms a right angle with either the ground or the desk, the table, whatever. If you hear the word vertical, you can go ahead and assume perpendicular. If you hear the word horizontal, chances are they're talking about left-right distance. So they're talking about your flat leg of your right triangle. Same with the word height. You can count on them talking about up-down. When we get to length and distance, you need to be really careful about what are they talking about length or distance of. If they're talking about how long is it to get to the airplane, that's going to be your hypotenuse. If they talk about the distance between the balloon and the tree, the trunk of the tree, that's going to be that vertical distance. So the hardest part about these problems is making sure that you are getting the legs of the right triangle and the hypotenuse assigned and sketched correctly. All right, do me a favor, study this picture and make a conjecture about the relationship between the angle of depression and the angle of elevation between the balloon and the tree. Talk to your group. Your mark is set, go. All right, so the conversation is, if my horizontal measurement is true, and my ground is true, I'm looking at two sets of parallel lines, or a set of parallel lines, because they are both horizontal. They are both, think about the horizon. So when I have this distance between two things, that ends up serving as a transversal. So if somebody is talking to me about an angle of depression from the balloon to the tree, or an angle of elevation from the tree to the balloon, we know that those two measures are going to be congruent. So the interesting thing is when I go to draw my triangles, a lot of times we want to make sure that we understand that you've got two options of triangles that are right. Whether you are talking about this triangle here with this angle of elevation, or this triangle here with this angle of depression, those are going to be two congruent triangles. So those angles are going to be congruent. The biggest mistake that people make is they think that this is the angle of depression. It is not. Your angle of depression has to be measured from your horizon down. Make sense? All right, so let's talk about this example. When a hockey player is 35 feet from the goal line, he shoots the puck directly at the goal. So here's his stick, and he's wearing a helmet, safety first. And here he is. His skates are very sharp. He's shooting the puck 35 feet from the goal line, directly at the goal. The angle of elevation, here's our elevation. Elevation is up, at which the puck leaves the ice, is 7 degrees. The height of the goal, here's the goal, is 4 feet. Now they gave us the word height here, so we're going to head and assume that this is that right angle. So if you're curious about what this box is, that's that right angle. And they want to know, will the player score a goal? Talk to your group mates about strategies and how you could answer that question. Go. All right, so if you draw a triangle, here's your theta, 7 degrees. Here is your adjacent leg with a distance of 35. I need to know how tall this is because here is the path of the puck. So I need to know when the puck reaches that, how tall is it going to be? I'm hoping the answer is less than 4. If it's less than 4, it goes in. If it's equal to 4, bonk, it hits the goal, it hits the crossbar. Maybe it then bounces in, maybe it bounces off, maybe it deflects. We don't know. But if it's bigger than 4, it's going to sail over top. You okay with that? So let's go ahead and let's figure out this opposite side of this 7-degree angle. So I know that my sine and my cosine and my tangent are my 3 choices of ratios. Which one would you pick? Tangent, because I have my adjacent and I'm looking for my opposite. So the tangent of 7 degrees is going to be equal to the ratio of my x value over my adjacent side. I'm going to go ahead and do my cross products. X is going to be equal to 35 times the tangent of 7. I'm going to get my calculator. I'm going to check that I'm in the right mode. Am I good?
Yes.
Okay. Second quit. And I'm going to say, hey, calculator, what is 35 times the tangent of 7 degrees? And it's going to tell me it's 4.9297. So X has a value, if I round up, of 4.30. 4.30 is where my puck is going to be. Do I score a goal?
No.
No goal. Yeah,
So the reason you didn't use 4 for X is so you can see it's moving before?
right. So the goal is 4, but that doesn't tell me that that's where my puck is. The 7 degrees. Now, I could switch this problem around. What a great question this would be if you said, the goal is 4, what's the angle got to be to make it? Because then my answer to my angle would have to be smaller than 7 degrees.
Right.
So we can switch that around and ask it in a bunch of different ways.
Okay.
Sound okay? All right, ready? On the back of the page. When you're looking at each of these angles, we have different angles of depression and elevation. Whether you're talking about the view from the boat to the birds, or actually this is a ship. From the ship to the birds, or the ship to the submarine. With your group, agree on which ones are angles of depression, which ones are angles of elevation. Go. All right, come back. When you look here, you can see I put a little red star because that's where I have to start from every time. So write yourself a note on your notes that you go back and review and study to remind yourself of all the things that you've forgotten, that you want to start at the horizontal. And you want to pay attention to whether you are measuring up for elevation or whether you are measuring down for depression. So we want to make sure that your notes are a good tool for you to come back and review when you forget what you used to know. All right, so in each of these 4 problems here, we've got scenarios, and we can talk about how the angle of elevation of the crane, or the angle of elevation from the boat to the plane, has a certain degree measure, or we could talk about the angle of depression that's from the, it's not a lighthouse because it's out in the woods, like an observatory, what do you call, like a watchtower, I like that. And then from this person down to his camper, I think that's his camper. So when it's drawn for you, it's no big deal. They're asking you to solve for the value of x. So they're not asking you to solve the triangle. They're just asking you to solve for whatever value you're looking for. Good news, that's a third of the work of what we've been doing. You're welcome. Now here's the thing here. For 3 and 4 and 5, your number 1 thing that you need to make sure you do is draw a sketch. So I'm going to skip 2 and jump into 3 and draw a couple pictures so that you're solving for the right value. When we talked about what homework you need to do, finishing these notes and that homework sheet I passed out to you before lunch, that's it. Make sense?
Yes.
Okay. So, you okay with starting on the pictures?
Yes.
Okay. Meaning drawing pictures, not these pictures. So we'll start with drawing the pictures. Ready? A person standing is 40 feet from a flagpole. There we are again with our flagpoles. Mathematicians love flagpoles. And they can see the top of the pole at a 35-degree angle of elevation. The person's eye level is 4 feet from the ground. What is the height of the flagpole to the nearest foot? Are you ready for this one? My person is standing here. Here is the ground. And his horizontal view of the flagpole is at a 35-degree angle of elevation. He's standing 40 feet from the flagpole, and his eye level is 4 feet from the ground. Let's talk strategy. What are you going to solve for first? The height of the flagpole from his eye level, right? Is that what you just said? So we're going to solve for x. How high is the flagpole?
4 feet.
Plus.
X.
So you're allowed to assign a variable for whatever it is you're solving for. I'm solving for x. Assign that variable. I'm solving for my opposite. I have my adjacent. Are you okay with this being a tangent conversation? Ready to draw your next one? You are standing 40 feet from a tree. Again, I'm 40 feet from a tree. It's Christmas. The angle of elevation of your eyes to the top of the tree is 47 degrees. So here I am. What's this dotted line?
Your horizontal.
Yep. And how tall am I?
Wait, actually.
5 feet. what is my angle of elevation to the top of the tree?
Five plus one.
So your height of your tree, if we make this x, is going to be 5 plus whatever value you solve for. Yeah.
So for questions about elevation and depression, is it pretty much always gonna be tangent?
Depends on what you're solving for. If they ask me for the distance from
Wait for it.
me to the top of the tree, that'll involve the hypotenuse. It just depends on what they're asking for. All right, everybody, have a good weekend.